Hi everyone, and welcome to this talk on working efficiently within the software. I'm Adam, and today with the help of my colleague Mike, we're going to talk you through some tips and tricks about how to work within the software more efficiently. So both Mike and I are members of the development team here at Vectric, and we've worked on the software for a number of years. And when you kind of work on the software, a couple of things tend to happen. So the first thing is that you're opening the software, you're testing features, you're writing features every day. And so you have to work really efficiently. You learn all the shortcut keys, you learn how to make jobs quickly, you learn the kind of ins and outs of all of the features that you're working on. And the second thing is that when a bug comes in, you have to learn the feature inside out. So you know all the kind of secrets, how it was designed, what the intention was when we made the feature. And I think over time, all of the developers tend to kind of have their favorite corners of the software, the bits that they've worked on that they really love, the paper cuts that they sort of solved. And so today we'd just like to show you some of ours. Some of this will be tips about working efficiently within the software, and the others will be kind of a couple of tricks about how you can use the software in non-standard ways to produce parts efficiently. So we hope that you find some interesting techniques here, and we're going to begin with some drawing tips with Mike.
So in this file, what I've got for you is some tips for the 2D drawing tools. Let's start with the Create Polyline tool, which is great for tracing bitmaps like this one just here. Just use left click to create straight lines, and then you can click and drag to make curved lines to fit the curves of your bitmaps, like so. Click and drag. Now, every time you click and drag, the software is going to assume that you want your next line to be curved, but if you don't want that, then you can hit S on the keyboard to make a straight line instead. And then you go back to clicking and dragging, or making straight lines, whatever you need. Now, say I make a mistake, like I've done here, what I can do is I can either come over here to undo in the polyline tool itself, or what I can do is I can hit backspace on the keyboard, which saves me having to go back and forth between the bitmap and the undo button. It makes for a much more smooth drawing experience because you get to keep your mouse in pretty much the same position. Still on the polyline tool, I'm going to show you next is how to extend existing geometry. So we've got sort of halfway through this tracing here. So you stop for whatever reason and want to come back to it. If you hold Control and click on the end of this existing line, you can actually carry on drawing from where you left off, and it'll actually add to the line that you extended from, instead of making a completely separate vector. So you see, if I just click on the end without holding Control, you make two separate lines. By holding Control, extends the existing line. And this holding Control to extend existing geometry is pretty handy when it comes to editing geometry of existing toolpaths. So for example, I've got this profile here that follows this curve, and if I wanted to maybe change the curve somehow, maybe extend it, then I can open the polyline tool, hold the Control key, click the end, extend it in any way I want, and then all I need to do is recalculate this profile toolpath, and it'll notice the change to the underlying vector of the toolpath and update the toolpath accordingly. Now over here, what I've got is some vectors set up for a sort of mirror or picture frame sort of thing. So this vector is going to be used to be pocketed out when you'd put in whatever you want it to be framed. And then I want to use these two vectors to make a sort of sun symbol to sit on top of the frame. So the way I'm going to do that is I'm going to have some vectors sweeping through these two arcs to make a sort of sunbeams, and then we'll have the sort of main bit of the sun just here. You'll see what I mean once I've finished. So let's start by just creating a single line. Make sure I've got snapping enabled, and then snap to the center of this circle, and then draw a line way over to the left. Now what I'm going to do is I want to sweep this line through these arcs. I'm going to do that by using the circular copy tool. So to start, I want to start rotating about this point here, So I need to change the center of rotation. At the moment it's in the middle of our vector, but if we click in the middle, we'll get this circle popping up, which is our center of rotation. We can just click and drag it to wherever we want. We want it in the middle of that circle. Next, make sure you've got rotate copies enabled, and we're going to have 11 copies of this line, and the angle between each line is going to be 18 degrees, and so we've got 11 lines, which makes a total of 10 different angles, and so we'll have a total angle of 180 degrees sweeping through these two arcs. So just hit copy. That's exactly what we get. This is what I was looking for. Now obviously these lines are extending way too far beyond the arcs. That's where the trim tool comes in. This will allow us to trim these vectors to the outer arc. If I just click on this bit of the line here, it will trim it to this arc. And the same is true for all of these bits. So that's just hovering the line and then left clicking. What we can also do, which is much faster and in my opinion a lot more satisfying, is you can actually hold down left click, and then whenever you cross over the line, it will trim it as if you've clicked on it. So just holding down left click at the moment, and then it goes over all of the lines, and it gets rid of all of them and trims them to the outer arc. And then I want to also get rid of all of these lines in their central arc, and so I'm just going to hold down left click again, and then get rid of all of them like that. And this is what I was looking for, like a sort of a sun symbol. Here's the main bit of the sun, and then all of these rays coming off it. Just to show you what that looks like, I'll create a quick profile. Doesn't really matter about the settings, just that I'm on the curves. So I'll click calculate, and then I'll preview both the toolpaths, because why not? Preview all toolpaths, cutting out the pocket for the frame, and then we have the sun symbol that sits on top of it, which I think looks alright. And all we used was the circular copy tool and the trim tool.
These are the 5 options that I always change when I start a new version of the software. The first is the Save Dialog Layout option. This just saves the position of the dialogues so that when you restart, everything is back where you left it. Option number 2 is the Auto Open 3D View. I always set this to no. If you do this, then after you've calculated the toolpath, it doesn't automatically open the preview window, which I find more useful, especially if I'm kind of iterating or testing. The third option that I always change is I bump up the recent file list size. This just gives you more options for recent files that you've opened, and if you've got a big enough screen, then you can have this up to 10 or 12. It can be handy if you're working through projects with lots of files. The fourth option that I always change is to show the clipart subfolder's contents. This just means that when I select a parent folder, then it shows all the subfolder content at the same time, which gives you a nice overview of all the clipart that you have. And finally, and I think most importantly, I always set the file dialog default to be operation. If you do this, then it opens the file dialog in the last used location for that operation. So you can have kind of different buckets for toolpath saving versus 3D model import, which is really handy if you've got common places for those operations.
In this file, we're going to be looking at the array copy toolpath, which is a really easy way to make a bunch of copies of existing toolpaths without having to worry about creating extra geometry or 3D models. For example, in this job, we have a simple Halloween piece made up of 4 toolpaths, all using different tools. We have a pocket toolpath to pocket around our 3D model, finishing toolpath to machine this pumpkin in the middle, some VCarve text, and then a final profile to cut the whole thing out. And here's what it looks like in simulation. Now, if we wanted to machine multiple copies of these from a single piece of material, there's some things you might try to do, such as just copying all of the geometry and the 3D model, make a bunch of copies, and then go through each of these toolpaths individually and select the necessary vectors. But you can imagine that would be pretty time consuming, and if you wanted to change the design in any way, for example, change some of the text, you'd have to delete all of the copies you'd made and then start all over again with the new design. So instead of worrying about that, the best thing to do is to use an array copy toolpath. So to do that, let's come over to the array copy toolpath down here. And now the first thing we need to do when using this kind of toolpath is select all of the toolpaths that we want to make copies of. In our case, it's all 4 of these toolpaths. Next we need to decide how many copies we'd like to make, and we do that by specifying the dimensions of the grid that our copies are going to make. So let's say we wanted to make 9 copies, we'd just have 3 rows and 3 columns to make a 3 by 3 grid. Next we need to decide how our toolpaths are going to be spaced out, and we can do that by either using an offset for each toolpath or a gap between the toolpaths. And this icon will change to show what each of these options are doing. Let's use an offset for now, and since the width of our outer circle, just here, is 5 inches, as we can see in the bottom right corner, width 5 inches, let's use an offset of 6 inches to make sure there's enough room between all the toolpaths. So we have an offset of 6 in the X direction and in the Y direction. Now if we hit calculate, we'll see that we've created a 3 by 3 grid of copies of our 4 toolpaths. However, these copies are running off the page because by default we create copies across to the right and up. So to change the direction, we can just change the sign of the offsets in here. So if we wanted to go left, we'd have -6, and if we wanted to go down, we'd have -6 here in the Y direction. So let's set the Y offset to be -6, and then if we hit calculate again, that will put all of our copies back into the bounds of our job. Once you've got your dimensions and offset set up correctly, you'll need to consider the minimize tool changes option, this one here. This option tells the software that you'd like to minimize the tool changes during machining, which in our case means that all of the like toolpaths will be machined together. So first, all of the pocket toolpaths will be machined, and then all of the 3D toolpaths, then all the VCarve toolpaths, and then all of the profile toolpaths. This is the option you'd use if you wanted to minimize machining time, since you won't have to be constantly changing tools. Not having this option selected means that each piece will be machined fully before moving on to the next. So it will machine all the toolpaths on this first piece, the pocket, the 3D finish, the VCarve, and the profile before moving on to the second piece and doing all the toolpaths on there, and then on to the third and all the toolpaths on there. This is a good option if you have some manual finishing that you need to do on each piece that you can do while the other pieces are being machined. Once the first piece is done, you can take it away and it can be finished while your CNC finishes off the rest of the pieces. So let's just hit calculate, and we can see what it looks like in the 3D view by just previewing the array copy toolpath. Finally, say we wanted to change the design. So instead of saying Happy Halloween, we wanted it to say Spooky Halloween. Then all we need to do is come into the text tool, change it from saying happy to saying spooky, and then we could just recalculate all of our toolpaths. See that all of the VCarve toolpaths in the copies have been updated to reflect the changes. Next up, I've got a couple of tips for automatically naming the tools in your tool database. So let's start by coming over to the tool database to have a look at our tools. And you've probably noticed that whenever you make a new tool, the software automatically comes up with a name based on the tool type and the diameter. So here we've got the end mill and 1/2 inch. That's the name that the software comes up with for this tool. And it does that because of the way that the name has been formatted. And we can take a look at this formatting by coming into the dialog for renaming the tool. Here you can see that the current name is made up of the tool type, the diameter, and the units of the tool in short form. You can browse all of the other formatting options by just right-clicking, and here you'll find all of the formatting options available for this tool, such as all of the geometry, the custom parameters, the feed speeds, the material, and the machine. And in the geometry, we'll see the tool type, the diameter, and the units in short, which are all used in the current name. To add a new parameter, all you need to do is just click one of these, and it'll automatically get added to the name. So here we've added the number of flutes that this tool has, and you can see in the preview At the end, it now says end mill, half an inch, and it's got 2 at the end because that's the number of flutes it's got. But just so we know what that actually means, we can come in here and write num flutes equals. And now when you look at the tool name, you can easily see how many flutes this tool's got. And you know it's always going to be accurate because we've used the name formatting. Now if you wanted all your future end mills to have this same sort of naming structure, then you'd keep this box here checked, set as default for end mill, so that the next time you create an end mill, the name structure will be like we've got here. And you can also update all of the existing end mills to rename them to also have this structure. So if we hit OK here, we'll see that all the end mills get updated. Some of them don't have the number of flutes set, and so we get this num flutes in curly braces in the name. So to fix that, all you need to do is add a flutes parameter here. Now, as well as having different parameters, you can also modify the parameters in the tool name by coming in here and using a vertical line after one of the parameters. So for example, this diameter has a vertical line followed by an F, and this F is an example of a modifier. It's saying that we want to modify the diameter to be represented as a fraction. If we were to get rid of that, it would be represented as a decimal. Also for letter-based parameters, you can come in and use a vertical line or shift backslash followed by a U to make it uppercase or L for lowercase. All of the parameters and all of the modifiers can be found in our online documentation, which you can access easily from this dialog by just hitting the F1 key on your keyboard. And that will open you up to our documentation for the name formatter for the tool database, which has a list of all of the possible parameters for the tools and also a list of all the possible modifiers.
In this tip, we're going to talk about how you can use 2D and 2.5D toolpaths to reduce the machining times and increase the quality of 3D parts. I have this job open here, and it's an assembly of 3D models. In fact, it's one of the assemblies provided with the Cottage Life project from the Waterside collection. And I'd like to machine this, so the obvious way to do this would be to do as I've done here, set up a finish toolpath, a roughing toolpath, and a profile toolpath to cut it out. And if I preview this, you'll see that this is the result that you get. Now I'm pretty happy with the way that this has turned out, but there are a couple of things that jump out. The first thing that I notice is I have this cup or lip here, so this cusping effect, and that's caused by the fact that the round ball nose that I've used to do my machining can't quite get in flat to this edge. So that's left a slightly unusual effect. And you can see this is actually exacerbated further down where we've got a little bit of detail by the edges, and so you get this strange effect where the tool can't quite fit into the material, and so you don't get the result that you'd expect. And the other unusual thing is that I've got this kind of border here, and you'll see that where this should be crisp and joined, because I've used a round nose tool, then again I've got a rounding effect here. And similarly on this corner right here. And finally, you'll see that this is all flat, this region here, but because I've just machined this as one big finish toolpath, then I've actually had to use the standard round nose tool, and so this is going to take longer than it needs to, and also I'm left with some kind of machining lines. So let's try and solve these problems one at a time, and we'll begin with the frame. We want to try and remove these rounded corners here and here, and would also like to improve the machining time. There is a kind of an additional kind of advantage of splitting up the frame as we will do, and that's that here the grain is going with the frame direction, but here it's running against it. So it'd be nice if we could actually always be machining along the grain of the wood. So I'm going to open up my frame sheet. And we'll press Shift and F6 to center that. Now you can see in the 3D view that the frame is actually a 3D model, and I actually want to replace this with a molding toolpath. So first I have to get the profile for the molding. Now if you created the model yourself, it's very likely that you had the profile for a sweep or a two-rail sweep, but in this case I'm using a pre-made model, so I actually need to get the profile from the model. And how I'm going to do that is I'm going to use the model cross-section tool. So it's pretty simple to use. You go into the 2D view and you just drag a line across, and it produces a vector which represents the cross-section of the model between those 2 points. What you probably then would like to do is just trim this vector, perhaps resize it ever so slightly, and also clean it up if necessary. And I've done that here with an additional cross-section that you can find at the side. So I'm just going to delete this new cross-section that I've made here. Next, I need to make the molding toolpath, and to make a molding toolpath you need a vector that you're going to sweep across and the profile, which we already have. This job already has a vector around the outside, but it's one single vector, and if I sweep this profile using the molding toolpath, I'd still have this problem with the rounded cusps in the corners. So actually what I want to do is break it into 4 parts. And to do that, I'm going to use this gadget up here. So if you go to Gadgets, Explode Vectors, and you have a load of options, but I just basically want to replace the existing ones, leave them where they are, and I always show the form just in case. And all that does is explode the vector into spans. So you see, if I delete the model, I now have 4 spans. And I'm now going to do the same with this interior vector 2. Like so. So next I need to create my molding toolpath. I'm going to select the rail and the profile, and I will hit calculate, and that's created our molding toolpath. And we also want to cut out along this shape here. So I will make a new vector that goes all the way around and profile around the outside of this vector. And if we do that for all 4 of our edges, then we will have the 4 parts of our frame. And we'll still need to, once we machine these, to fasten them together in some way. One suggestion I had from Todd is that you can use butterfly joints on the back side, which might be quite a nice touch. Another thing I saw online is using a jig. So you can machine one of these jigs here. If I turn those off, I have two pieces of MDF, and then apply a vice grip on either side to allow you to join these corners together. And that's the frame complete, so let's move on to the central design. So what we're trying to do here is we have this simple 3D model that we want to machine, but we have an area that's kind of going to be flat that we'd rather not use a finish toolpath for, but actually use a kind of pocket toolpath, and we're going to want to cut out around the edge. Let's go to the 2D view. In order to kind of pocket this area, we need a vector that represents it. So I'm going to select the 3D model and choose this option here to create the boundary vector. I'll just turn off the 3D model for a moment. I'm going to use the D key here to delete some of these edges, and E to extend, just to get the shape that I want to pocket. And in fact, because I want to pocket and completely remove, if I don't extend here, then I'm going to be left with an unmachined area at the corner, and I've worked really hard to avoid such things. So what I'm going to do is I'm just going to drag out this section like so. Now if you probably doing this properly, you'd be more precise and add on exactly the tool radius. So next up we need to make our toolpaths. I'll turn this model back on. Let's do the finishing toolpath first. So I will calculate here to create the finishing toolpath, and I'll also now select this vector here and create the pocket toolpath. And the cut depth here has come from the thickness of the model. So if I double click the model in the model entry, you see 4.874, which is exactly the value here. And let's preview all these toolpaths. So you see we have our 3D toolpath and then the pocket. And finally, we'll just need a cutout toolpath around the edge. So calculate, preview, and that's our central design complete. One nice aspect of this splitting is that the central design is completely independent, so we could machine it in a different material. We could use a thinner material, which means we wouldn't have to remove as much material if we had a kind of a roughing process. That would make machining times even quicker. And if you add up the actual values of the toolpaths in this job, then just do it in one go would take 2 hours and 20 minutes according to the estimation. Whereas splitting it up into these separate toolpaths, the total comes in at 1 hour and 45. So a significant saving in time as well.
In this document, what I've got is some vectors set up to show off some stacked text, or text on text, where this Vectric text sits on top of the UGM text. I won't be showing you how to set up a job like this because we've got plenty of tutorials online. Just search for Vectric stacked text and you should get some tutorials coming up. What I want to focus on is how I can use document variables in a job like this to make my life easier when editing existing toolpaths. So let's start by taking a look at what we've got in this job in terms of toolpaths. We've got 2 pockets, each with a clear and a finishing pass. So the first toolpath goes around just the Vectric text, and it cuts at a cut depth of 0.04 inches. And then this second toolpath goes around the whole of the Vectric and the UGM text, and it has a start depth of 0.04 inches, which is the cutting depth of the previous toolpath, and it goes down an extra 0.05 inches. So if we take a look at what that looks like when it's simulated, we get something that looks like this, with the Vectric text sitting on top of the UGM text. And I've added some colours to make it pop out a bit more. Now, say I wanted to change the cutting depth of this first toolpath. What I could do is I could come into the first toolpath and then just change the cutting depth here, but then I'd have to remember to also come into the second toolpath and remember to change the starting depth here, because this starting depth relies on the cutting depth of the first toolpath. Now that's not too bad with just two toolpaths relying on a common value, but you could imagine if you had lots of toolpaths relying on the same value, having to go through and change them all would be pretty laborious and time consuming, and there'd be a lot of room for error. If you messed up one, you might not know which ones you messed up. So what you can do instead is, when you're setting the cutting depth for this first toolpath, instead of just writing 0.04, we can instead include a document variable. So if you just right click and click Insert New Document Variable, we'll be prompted to give this document variable a name. Let's call it the top text depth, and we'll set the value to be 0.04 like it was before. So now instead of 0.04 in the cutting depth field, it now says top text depth, and so the software will then interpret that as 0.04 when it's calculating the toolpath. So if we just hit calculate, we should have the exact same toolpath we did before. Now what we can do is we can come into the second toolpath and change the starting depth in here, get rid of this 0.04, right click, and we just need to click on the top text depth that's already there in this drop down menu, and then hit calculate, and that will again be using that 0.04 value for the start depth. Then if you wanted to change the cutting depth of the first toolpath, instead of having to go in to both the toolpaths and change the values manually, you can come over to Edit, Document Variables, and you can just set the top text depth straight from here. So to say, instead of 0.04, we'd go 0.08, hit OK. Then we'll be warned that all of the toolpaths that use the document variable need recalculating, which is fine. Just come, hit recalculate, and we'll see, if we take a look here, that the max depth of this toolpath is down to 0.08 inches, which is what we set our document variable to. One last thing to mention about document variables is that they can be used anywhere in the software that uses these number edit boxes. You may not know that these boxes support some special constants. For example, if you want to get the value of pi, you can hit P and then equals, and the software will fill in the value of pi for you. Now you can add in your own constants by using document variables. For example, if you use the square root of 2 a lot, you could add in your own document variable called the square root of 2, which is about 1.414. And then whenever you wanted to access that value, you could just get the document variable, hit equals, and the software will remember that value. And say you wanted to get something like 2 times the square root of 2, you can hit 2 times, then right click, get the document variable, hit equals, and the software will also calculate that for you.
In this tip, I want to talk about how you can use toolpath templates and job templates to work more efficiently within the software. Now, if you're anything like me, then as you watch the tutorial videos or the other talks, and you see presenters talk about how you should organize your job into layers and use the toolpath templates with those layers, then you might be thinking, that's all well and good, but I'm just not that organized or I don't work that way. And I'm exactly the same. However, one little trick that I found to help encourage me to get a little bit more organized is to set up job templates with empty layers for my common tasks. This helps prepare me for getting organized at a later date. So for those of you who don't use this feature often, job templates are just really regular old CRV or CRV 3D files, except for two key differences. So the first is that they have a different default opening directory. And this is really handy because it means you can have a single directory where you store all your templates. And the second thing is that when you open the file, it opens like a new file. So that means you can't overwrite it, and you're prompted with the job setup form where you can specify the job dimensions and the machining parameters. But apart from that, they're exactly like CRV or CRV 3D files. And that's great because you can fill them with anything you like, and that includes layers. So what I'm going to do right now is I'm going to make a new job template. I'm coming here and I'm making a new file. Like I said before, you're actually prompted with the job size, and I'm not actually concerned about a specific job size right now, so I'm just going to leave this as the default settings. But I usually would set the Z0 position and the XY datum position to be the ones that I would typically use, which is material bed and bottom left hand corner. Okay, and now what I'm going to do is I'm going to add some layers to my job. So I'll open the layers tab, which is now on the left in version 11, and come here and hit add new layer. And I'm going to add in a cutout layer, a hold down layer, a layer for dowels, a layer for any dimensions, and a reference layer where I might store any reference geometry or images. I'm going to turn the reference and the dimensions layers off. I'm going to make the dowels layer this green color, and I'm going to set layer 1. First of all, I'm going to leave it in there because it's the default layer name, and I'm going to make it the default layer. And then I'll hit File, Save as Template, and I'm going to choose this with layers option and hit Save. Here you'll see I've been prompted for confirmation, and I will replace. Let's close this down, this file. And now if I ever want to use this template, I use this new file from template option and just choose the option that I want. So the with layers option here. Hit OK. And you see it's opened up the file. And if I look in my layers list, it has all of the layers that I want, including the visibility and the color settings. So what's really nice about this is that now I have a standard set of layers. I can kind of exploit this knowledge in other ways. So one thing I have, for example, is if I go to the clip art tab here, you see I have this 2D geometry folder. And within that, I've got just a small selection of bits of geometry that I would use frequently. For example, I have some dowels. And here you see I've got some metric dowels and also some imperial ones. I'm just going to drag in this 1/4 inch dowel. You see straight away that it's actually green. And the reason it's green is because when I made that job, I put the dowel on the dowels layer. And so when it's imported, it goes onto the same layer in the new job. And so the fact that we know what our sort of standard layer names are going to be is really helpful, because you can kind of get these compounding benefits. And I can bring in a few of these dowels and just sort of put them in my job. Maybe I was going to use them as kind of reference, like so. Another nice way you can use this is I could now go to the toolpath tab, and I could load a template. And I've got a template here called drill dowels. Whenever I hit open, it brings in the toolpath template. And if I recalculate this, you'll see it's automatically drilled holes for the dowels. And the reason it's able to do this is because if I look in this toolpath and the selector, it's an automatic vector selection, and it's picking up vectors from a specific layer. So once again, we're able to just use the fact and exploit the fact that we know what these kind of standard layer names would be. So it's kind of a really handy way of working. This automatic vector selection association that we've used here is really powerful, and it's especially powerful if you have these standardized layer names. But if it's not possible for you to have this kind of level of standardization, or your job is just not structured in that way, that doesn't mean that you can't use toolpath templates for other interesting things. So what I'm going to do is I'm going to open up a job I've created previously to show you some ways in which you can use toolpath templates manually. So let's get File, Open, and I'm just going to open up this project right here. In this job, I've got a number of examples of how we can use toolpath templates. But first, let's just remind ourselves of how we go about making a toolpath template in the first place. So I'm going to select this sheet and press Shift and F6 to focus on it. And I'm also going to pin out the toolpath tab. You can see in this job we have a single cutout toolpath. It's a profile toolpath, and it cuts through all the way through the job. So I've done a couple of things here to prepare this toolpath to be used in a template. The first thing is using the variables, and that's ideal for templates because if the job thickness changes, then the profile will still cut through the job. And the second thing that I've done is I've used an automatic vector selector. And here I'm selecting all closed vectors on the cutout layer, and I'm associating with the toolpath, so it automatically picks up the vectors when I recalculate. So let's just hit calculate here, and you'll see it's selected the vectors on that layer and it's made the cutout toolpath. So if I go now and save this as a template, and I'm going to choose this pre-use name auto cutout. Let's just replace. Then if I switch to the next sheet, I can load the template I've just saved back in. It will prompt me to ask whether I want to apply the template to all sheets. I'm going to say no. And you see it's made this cutout toolpath. And if I recalculate this toolpath, you can see it's successfully recalculated and has selected all the vectors on that layer. So now I'm going to switch to the third sheet in my job. And you can see that these vectors are not on the same layer, they're on this other not cut out layer. Because these vectors are on this not cut out layer, then that means that I can't use my existing toolpath template. But I'd still like to be able to preload the toolpath with the thickness set, with things like allowances, tools, etc., all set up for me. So what I'm going to do is I'm going to go back to my first sheet, and I'm going to just come here and select this toolpath, and I'm going to change the selector to be a manual one. So I'm not going to associate, and I'm going to call this manual cutout and hit calculate. So it's exactly the same, except it's got no automatic vector selector. And now I'm going to save this as a template. I'm going to choose cutout manual here, hit save. I'm going to be prompted to replace, and I'll say yes. And I'll go back to the third sheet. So now I'm going to just import the template. I'm going to just apply to this sheet. I'm going to select just some of my vectors, and I'm going to right click on the imported toolpath, hit recalculate, and you see now it's created this manual cutout toolpath, but just using the vectors that I selected. So this is a really nice and powerful feature because it means you can save effectively properties of the toolpath and reuse them. And there are lots of cases where you might be doing things like setting specific allowances for inlays, or choosing particular tools or combinations of tools. And this allows you to reuse them without being tied to a specific naming structure for your layers. So I'm just going to show you another example. One of the really nice things about toolpath templates is that you can apply them to multiple toolpaths. So it doesn't have to be just one toolpath. You can select multiple and create your own templates. So here's just a kind of standard 3D component. Now, if you're machining things of the same size and you have a common tool set, then you're probably used to just creating the same toolpath over and over again. So what I've done is I've made a template, my 3D machining template, and if I open this up, you'll see it creates two toolpaths. It creates a roughing toolpath and a finishing toolpath. And if I just recalculate all of the toolpaths here, and look in the 3D view, so this is finished calculating. You'll see it's created a roughing toolpath where it rasters horizontally, and a finishing toolpath where the cut lines are vertical. So you can set up these kind of configurations of commonly used patterns of toolpaths. I think this is a really powerful tip. That's all today for our developer efficiency tips. We hope that you've found something interesting in the talk. Both Mike and I and all the developers from Vectric will be around in the chat to ask any questions to throughout the rest of the event. And we hope you enjoy the rest of the user group meeting. Thank you.